Okay, so today we're going to talk about how to triage a process. And what this refers to is, if you're in a situation like maybe manufacturing, you may have multiple process streams and they may not all be, operating at the same level that you would like them to. But you may also not have unlimited resources to, fix everything at the same time. So this matrix or this table kind of helps guide you through some scenarios to help allocate those resources to the most urgent situations. So, for example, we have a set of criticalities going from non-urgent all the way up to urgent. Okay, and of course you can change these labels based on your business as well. And the two aspects we're really looking at are the process behavior, okay, the process characteristic, and then let's say the product characteristic or the output. So we'll use like control charts to understand process behavior and then some kind of capability analysis to understand the output. Okay, so then we'll be comparing the the process output to some, let's say, requirement or specification or something like that. So if you don't understand, control charts and capability analysis, there's a lot of resources out there, but that's something that you can definitely investigate as well. So in this situation, we may have some process generating some output over time that's graphed here, and some kind of control limits have been established. Okay, the control limits would kind of speak to the variability of the process, and here we would be looking for assignable causes of variation, or what is the common cause or special causes of variation, common versus special causes of variation. And using some kind of rule set to determine if a product is predictable and has regularity of output. So here we have a process that appears to be in pretty well good control. And then the second aspect is how well does it conform to some kind of requirements. So here we might have some specification limits. Here's a very idealized distribution of the output, and it seems to be conforming pretty well. Okay. So this would be a situation. It kind of falls into the camp of, hey, if it ain't broke, don't fix it, right? So in this situation, you'd want to probably leave it as is and maybe just monitor for any kind of changes that may be, coming down the road or something like that. Now, of course, the data for your own process, will come from, measurements or some kind of metric that you're taking. So in manufacturing, it might be, an actual physical dimension. If you're in a sales organization, it could be revenue, or anything like that. So these ideas apply to a lot of different situations. The next one is, a process that again is in control. So again, nothing big happening here, but even though the process is in control, it may be generating a little bit more variability than you would like, let's say compared to some kind of specification limits. Okay, so you can see that the distribution of values is actually coming out of the sides here. Chances are you're making some kind of non-conforming product. Even though your process is in control, you definitely want to look at ways to reduce that variability. Okay. I also want to point out, that the control limits here are not the same as specification limits here. So a lot of times people get confused. They're like, well, the graph shows everything's, within these limits. Okay, and they're thinking those are specification limits, but they're not. They're control limits. Specification limits, are fixed limits based, again, on some kind of requirement. So people get those two kind of confused, and they're two different things. But they speak to the same ideas, right? One speaks to the natural variability of the process, and one speaks to how that variability conforms to some kind of requirement. The next one is even more urgent. So here we have a process that's not in control. So maybe it was in control at some point, and then something happened, and all of a sudden there was a process shift. But yet it's producing product that's conforming. So you may say, well, what's the big deal here? I mean, I'm producing an output that's still conforming to some kind of requirement here, right? Well, the big deal is if you don't understand what causes the instability in your process, that can come and bite you later by, a process that balloons out of control with variability or process shifts and so forth. So even though you might be enjoying some success today, if you don't understand your process and what's causing, instability in it, this may not be the same tomorrow. So again, this is why it's really critical to address the predictability part of a process, you know, really first in a way. And then the next one is really the worst, which is the most urgent, okay? And this is really double trouble. So here we are not in control, so we can actually see values, above and below the upper and lower control limits. And we're also non-conforming too. So now we got double trouble. A process that's not predictable, the regularity of the output can't be assured, and product that's really not conforming. Here's another point to make as well. Sometimes people confuse a poor capability of meeting requirements as being out of control. So they may say, well, this process is out of control. Well, it is out of control, but this is a different situation here. So for example, in this situation here, yes, we had a process that was in control, but it was producing non-conforming product. So just because it's creating non-conforming product doesn't make it out of control, okay? And I've heard people say that quite a bit over the years. They say, well, the capability is not good, the process is out of control. Well, it may or may not be. That's what you have to actually assess with these control charts here. So that's pretty much it in a nutshell, how to kind of maybe, define your processes, to kind of see where your trouble spots are and how to allocate resources. Of course, this data comes from your process and can be analyzed, using control charts and capability analysis. There's a wide variety of software out there that can do this. And, if you compare, the output of your process against this chart, it can definitely help you address some of those problem areas in the most effective manner. I hope this helps, and good luck on your continuous improvement efforts.